Hello everyone. So today I am going to tackle another way to calculate electric field. Okay? So last time we calculated electric field from using the Coulomb's law that we had, diba? So the electric field is we from discrete charges and we replace the summation to integration because we are dealing with continuous distribution. So kaya I have Mm, kaya I have given you the table of integrals so that dili na ta sige og derive og mga integration, so di na ta sige og techniques of integration kay mawala ang essence sa physics. Okay, so that's why I give you the table of integrals to guide you. Now this another way to calculate electric field will eliminate all those unnecessary, di siya necessary, those very long integration. Okay, so this is a technique called Gauss's law. So Gauss's law is actually a very important part of physics law because it will simply uh, calculate electric field by using the concept of flux. So by the way, what is electric flux? So we'll start with by the definition of electric flux before going into Gauss's law. So what is electric flux, by the way? So electric flux, from the word flux, is a flow of electric field lines. Okay, so electric flux is just the how many lines are kanang penetrating or intersecting to a certain area A. Okay, so we have to calculate electric flux. The definition of electric flux is given by this one. So the flux is given by the symbol phi is equal to E times A. So your E is actually the magnitude of the electric field and your A is your area. So this can only be used if your E is uniform at saka yung A mo has a definite area. So meaning definite area, alam mo yun beforehand na ano ang area ng specific area mo, 'di ba? So ang kuanan na is this one. For example, I will give you something. There is a atong word. So I have here, so the electric flux. So nakoy area A diri. So suppose ang area A nako is square. We know beforehand that the area of a square is just, so suppose meron siyang side na S, is S squared, diba? So then your E is uniform ito, so meaning constant siya for that specific area A. So we have to the electric flux will be the one who will tell us kung how many field lines are intersecting on those in a specific area A. Okay, so kani nga equation is actually only true if your orientation of your A is given by this. So parang yung plane area A mo is exactly perpendicular ng electric field lines mo. Okay, so yeah, so this is just actually a special case lang. Okay, so yeah, the next is, how about if your area A is not perpendicular to the field? Okay, so what I mean here is that what if yung area mo A is slanted at an angle phi or rotated at an angle phi, as you can see here. So before doing that, generally kasi yung general definition mo ng electric field ay ng electric flux is given by this E dot A. Okay, so where your E dot A is equal to EA cosine of phi. So before dealing with this equation, so as you can see here, yung area mo is nagiging vector. So paano nagiging vector yung area A mo? So as you can see here, by definition, your vector area A is given by the magnitude A tapos merong unit vector na n hat. So this n hat means na normal. Normal means it is always perpendicular to a specific area, itong vector area A. So since yung vector area A mo is proportional to n hat, so meaning same sila ang direction ni n hat, yung vector A mo. So remember, by definition, yung n hat mo is always outward for the closed surface. Okay, so what do you mean by that? So if meron akong closed surface, for example, I have here a circle. Okay, meron akong circle. Okay, so yung circle mo is composed of many areas, di ba? So I mean, yung sphere mo is composed of many areas. So what will happen is always for that specific area, yung n hat mo is always perpendicular to that specific area A. So ito yung sinasabi niya na always perpendicular yung n hat mo. Okay, so n hat is just a unit vector ha, so it will not change the magnitude of your vector area A. Unit vector means yung magnitude niya is always equal to 1. So it just specifies the direction of your vector A. Now, balik ta dire, E dot A. So since yung A mo is always perpendicular to the area, so as you can see here, ito siya, perpendicular to the area A, so as you can see here. Now, yung phi mo dito is actually the angle between the electric field vector tsaka yung area vectors. As you can see here, ito yung electric field vector, ito yung area vector. So bakit nagiging equal yung phi dito at saka phi dito? Because once you rotate the for example, ito muna siya, di ba? So i-rotate mo siya at angle phi. Okay, ang angle phi. So what will happen is that yung A vector A mo will always follow the rotation. Kaya yung rotation niya, yung phi dito is actually equal to the phi here. Okay? So now, since na may orientation na phi ang imong area, kaning slanted area, so ano pala yung contribution ng phi mo dito? Actually, what you're going to do is you have to get the projection of your area A, para maging perpendicular siya ni electric field. Okay, so what I mean is perpendicular ha. So remember, what I mean here nga perpendicular is yung plane area A mo is perpendicular to the vector E. So hindi yung vector area A ang perpendicular ni E. Okay, there is a difference. So ako na lang i-paraphrase. So we have to project this area to para ang vector E mo is in the direction of your vector A. Okay, so kagets, so dapat same sila lang direction. Okay, so what will happen is this. So I will just again draw something. So here meron tayong from here, ito siya, di ba? So ito yung area A mo. Tapos nag-rotate din mo siya, nagiging ganito na siya. So ito yung rotation niya. So nagiging slant na siya. So sorry about the drawing. So with specific area A, okay, area A. So remember, from here, straight line lang yung A mo, okay? So the vector area A is the same direction as your n hat, okay? So yung A mo dito is the same gihapon, so perpendicular to the area A, the plane area A, yung vector area A mo dito with the direction of n hat. So same lang sila lang direction. Okay, so next, so since kay girotate man nimo ang imong area at an angle say phi, okay, so what will happen is the electric field is in ang angle between the electric field and the vector area A is phi, diba? So therefore, because of this angle, what will happen is that your area, vector area A, kinaa siya two components. That is A sine theta tsaka A cosine theta. So which of the components are actually which of the components is yung may contribution ng electric flux? So as you can see here, kukunin lang natin yung yung projection ni A, vector A, in the direction of E. So ito siya. So ito yung A cosine theta. Tapos ito yung A sin theta. So therefore, si A cosine theta is in the direction of your E, which is our aim. So ito yung nag-contribute ng electric flux. Okay, so ito kasi siya. So parang ito yung vector A, di ba? So vector A may angle phi. So the vector A is composed of the A cosine theta. So ito yung A cosine theta. At ito naman yung pahigda si A sin theta. Okay? So, is it pahigda? I think this is wrong. So ito ba? Sakto ba? So in the direction of your A cosine phi. A sin phi. Yeah, your A sin phi is actually pahigda. Okay, mura siya ginani diri. So, di ba ang A cosine theta is in the direction man? So, pahigda na imuhang A sin theta because the direction of your A sin theta is perpendicular with the electric field. So, meaning ito yung A sin theta mo. So, what will happen is naging perpendicular siya ng electric field. So, as you can see here, sa A sin theta, sa sin phi mo, or sin phi pala ito, hindi theta. Sin phi mo is walay ni penetrate nga electric field lines sa imong A sin phi. So, that is why wala siya contribution sa electric flux nimo. However, yung A cosine phi is, as you can see, meron talaga siyang na intersect ng mga electric field lines sa imuhang A cosine phi, the component, one of the components ni vector area A. Okay? So therefore, we can generally say na yung electric flux mo is given by E A cosine phi, which your A cosine phi is the component of your area in the direction of your E, which I told you sa katong-atong gidraw nako, which in vector form can be written as the scalar product of A E dot A. Okay, so meaning ng E dot A is we just have to get the projection of A in the direction of your E. Okay, so that is when A cosine of phi. Now again, yung yung general definition mo is merong phi, di ba? So ito yung mag-represent ng angle between the vector A tsaka vector A. Okay, so for example, like this one, ito yung pinaka first case, di ba? So what is the angle between the vector E and the vector A? Okay, so this is actually 0 kasi parallel sila. So it is actually not, ang phi mo is actually not the angle between the plane area A and the vector E. Okay, so this is correct. This is incorrect. So yung angle mo is the angle between the vector E tsaka ni vector A. So how about this one? So yung vector area E mo is going in this direction, tapos yung vector area A mo is perpendicular always to the plane area A. So ano yung angle ni vector E tsaka ni area vector? That is equal to 90 degrees. So cosine of 90 degrees, as you can see here, the electric flux is 0, which of course walang ni penetrate, diba, na electric flux. Okay, so mo na ang kung ipasabot na phi dari. Okay, so how about if naatay flux of a non-uniform electric field? So kani siya, these two equations are only true if again your E is uniform, meaning constant through a specific area A, tsaka yung A mo is my definite area, na alam mo beforehand ang formula ng area in question. Okay, so here, how about if naatay dili constant nga electric field o dili po definite ang area? So unsa man ato pagkuha sa expression for electric flux? So ang pinaka general expression gid sa electric flux is given by this and not this. Kasi this one is for electric field nga uniform, tsaka yung A mo is definite, may definite shape. Ito, even though yung E mo is not uniform, even though yung DA mo ay yung A mo is not in a definite shape, you can actually use this one. Okay? So, how to interpret this equation? So, as you can see here, meron tayong definite nga shape. I mean, irregular nga closed surface. So, I will just put it this one. So, ibutang sana ako sa document. So, suppose na atay irregular surface. So, here, akong ikuan lang ipadako, okay? So, suppose na ako'y source charge dire, the source of electric field line. So, for example, kung positive akong source charge, it will, iyahang electric field is outward, di ba? So, ang electric flux is always specific kung saan yung electric field na kukunin natin, di ba? Within those mga area. Okay? Kasi dito nagpe-penetrate yung mga electric field lines mo. Okay? So remember that your electric field is inversely proportional to 1 over the r squared, the distance between the source charge tsaka yung field point mo. So suppose yung field point natin is located on the, say, that point on the surface gud sa imuhang irregular nga closed surface. So this is called P1, and we have to say that this is called P2, the field point 2. So we have to take note of that. Then again, so your flux is just equal to, suppose magkuha ako og gamay nga surface nga ni-intersect ani nga area. So I will call that one as dA. So sa dA or delta A I. So that is for specific. So that is yung contribution ng flux mo. So a small contribution of the flux kasi gamay naman ang imuhang area. So suppose yung vector area mo, suppose lang ha, is in this direction, which is still perpendicular. Okay, dito yung delta A I mo, so that is vector, still perpendicular, but yung electric field mo, so suppose meron tayong electric field na gamay pod for this area, na siya'y angle nga say phi I. Okay, because gamay naman siya. Okay, gamay nga contribution of electric field, gamay pod na contribution ni surface area A. Okay, so yeah. Is it gamay? Okay, so I think this is not small lang, okay? So for a specific area A kasi, yung area atong gipagamay, hindi yung electric field. So pagamyo na to ang area A1, so with the angle phi I na electric field I also. So yeah, so we can put this one as EI. Then we have to take the summation of all the contribution of the electric flux. So ato yung i-add ni tanan dire. So we have here EI dot delta AI. Tapos we have to take the limit as your delta AI goes to 0. Meaning pagamyo nato ang ato ang area such that yung yung electric field mo that area is approximately uniform. Okay? So at saka approximately definite yung area mo, di ba? So by the language of calculus, so this is will just equal to the integral of E dot dA. Okay? Or since yung A mo is actually equal to A n hat, I mean yung dA mo is actually equal to dA n hat, so we can rewrite this one as E dot n hat dA and this is over a closed surface. Okay, so this is a closed surface. Okay, so yan yung definition natin ng electric field mo. I mean, the flux of a non-constant nga electric field. Okay? So, okay, so, sorry pala, hindi ko pa na point out. So, remember, what do you mean by flux of a non-uniform electric field? So, over a closed, irregular surface area, irregular closed surface kasi, so as you can see, my field point P1, suppose meron tayong field point P1 at saka field point P2. So sa field point P2 is closely close kayo or near kayo siya ni source charge, then therefore mas dako ang imong makuha nga electric field kaysa ni electric field at point P1 kasi mas layo man si P1 sa source charge. Okay, so this is what I call as non-uniform. So meaning sa over the surface in question mo, non-uniform sila yung electric field mo. Okay? So kanimang good, we actually say nga over the surface or over the area, yung electric field mo is uniform. So meaning makuha mo talaga yung uniform ay constant yung electric field over a surface, whichever surface you are dealing with. Okay, so that is actually the electric flux of a non-uniform electric field. So let's answer this one. So electric flux through a cube, an imaginary cubical surface of side L, is in a region of uniform electric field. Find the electric flux through each face of the cube and the total flux through the cube when it's oriented with two of its faces perpendicular to E. So there are 6 faces of a cube. So as you can see, each of the faces represents a vector area. So for example, itong face na ito, we have here vector area A1. So with a normal unit vector n hat 1, tsaka yung n hat 2 A2, n hat 3 A3, n hat 4 A4, and so on. Okay, so we have to find the flux through each face of the cube and calculate the net or the total flux. Okay, so how to do this one? So I will just put it in the word para makita nato. Okay, so na ako cube, para ako na ko si cube. Okay, so diri daw ko no is si A2 ay A1, which represents the n hat 1. Then the other face opposite to A1 is A2 with the normal unit vector of n hat 2. Then padidto nga face is si A3 with the normal unit vector of n hat 3. Tapos this face paatubang sa atua is si A4, which has a normal unit vector of n hat 4, tsaka yung top face ng cube mo is si A5, vector area A5. So with the direction of n hat 5, and then bottom face mo is si A6 with the direction of n hat 6. Okay, so the electric field is pointing through 2 faces of the cube. So ito siya, so penetrating only A1 at saka A2. So let's find the flux through A1. So we have here E dot A1. So I will not anymore put subscript of E for that face kasi uniform kasi yung electric field natin based sa atong problem. Okay, meaning constant siya over that surface. Okay, so we have here E a cosine of phi. So what is the angle for the area with respect sa imong E? So here yung area A1 mo is padung diri, ang imong vector E is padung diri. So meaning nag-ana siya. So diri imong A1, diri imong electric field. So what is the angle of them between them? That is equal to 180 degrees. So we have here E A cosine of 180 degrees. And then since cube ito, so each face of the cube is naatay square, di ba? So what is the area of a square? So that is just equal to E L squared, kasi yung side ng cube mo is na ay length L. So cosine of 180 is -1. So ito yung electric flux through A1. So how about electric flux through A2? So ano yung same gyapon ng ng formula. So E dot A2, again wala gyapon subscript imong E. So we have here E A2 cosine of phi. So I will just put 1 here para dito malibog. That is phi 2. So E and A2 is in this side. So ano yung area ng face dito? So square man sila tanan for a cube. So that is equal to L squared. Then the angle between your electric field tsaka ni A2, so remember, si A2 is going in this direction and then your electric field is going in this direction. So the angle between them is 0 degrees. Okay? So the angle between them is 0 degrees. So cosine of 0 is equal to 1. So we have a positive flux in A2 na side here. How about A3 na side? What is the flux sa A3? So the flux of A3, since it is pointing there, diri, so as you can see here, kaninga face, walay nakapenetrate nga electric field because the electric field is penetrating only A1 tsaka mogawas siya ni A2. Okay? So therefore, so without calculating good mismong electric field, we know that the electric flux is 0. And the reason for that also, so other than that, so other than walay ni penetrate ng electric field line sa imuhang area A3, so other than that, the angle between electric field vector is perpendicular to the vector area 3. So perpendicular siya, so meaning cosine of 90 degrees is 0. So that is why we still get a 0 electric flux. So how about for A4? So again, A4 wala po naka-penetrate ng electric field lines dari nga face, di ba kani nga face? So therefore, still actually equal to 0. How about sa top face of the cube? Again, wala naka-penetrate. So still equal to 0 yung electric flux mo through A5, and same also sa bottom face of the cube, which is the flux through A6, which is still equal to 0. Okay, so yun lang. That is actually electric flux. So kung pa man tong total electric flux, so what is the total electric flux or the net electric flux? So we just have to add all of them, each side sa cube. So we have negative EL squared plus EL squared, tapos meron tayong 0, 0, 0, 0, 0, so that is equal to 0. So the total electric flux through that side of the through this cube is equal to 0. Okay? So next problem naman natin is we have a closed triangular box resting within a horizontal electric field. Okay, so again yung electric flux natin is always remember na close yung ating always over the closed surface yung ating i-calculate na electric flux. So ito lang, hindi siya close because actually this is just excuse me, this is just actually a part of a closed surface nga area. Okay, so para makita ninyo ang direction for that specific area. Okay, makita ninyo ang electric flux. So that is why makita nato nga we have a closed cube U and we have a closed triangular box. Okay, for example, sample problem number 2, we have a closed triangular box resting within horizontal electric field of magnitude 7.8 times 10 to the 4th Newton per coulomb as shown. So we have to calculate the electric flux through the vertical rectangular surface. Okay, so we have this one. So A, we have to find the electric flux through this one, the rectangular, at saka yung slanted surface, so ito, and the entire surface of the box. So we have to calculate the entire surface of the box, calculate the electric flux. Okay, so I will just put it here again in my Microsoft Word. So we have here a triangular box. So I would just put this triangular box. Okay, so na ako'y anak diri, then anak diri, then anak na pod. So I have here, so mo ni ang triangular box nga naay 30 cm on this side at saka may 10 cm on this side with an angle of 60 degrees in this angle. Okay, so we have to find first the electric field on this rectangular vertical rectangular surface. Okay, so the electric flux for the rectangular is actually equal to same lang gyapon E dot the area of the rectangular. Again, wala ako'y gibutang nga E-rect diri because the electric field is uniform for this triangular box. So we have here E A of the rectangle, we have the cosine of phi. So what is your E gani? What is the magnitude of the electric field? So that is 7.80 times 10 to the 4. So we have here 7.80 times 10 to the 4th Newton per coulomb, but we don't know anything about the rectangle, the area of the rectangle. Okay, so the area of the rectangle is just equal to length times width. So with the length as 30 cm, but 30 cm is not an SI unit, so we have to convert that one, that is in meter, as 0.3 meter. Tapos yung width mo is 10 cm or in meter, that is 0.1 meter. So the area is actually equal to, ano yung area mo? 0.03 meters squared. So I will put it here, 0.03 meters squared. Pero ano yung angle between ng vector area at saka ng vector field mo? So remember, for this area nga for this rectangular surface, the vector area is always perpendicular. Okay, so diri siya. But the electric field, kung makita na to sa ato ang problem, ng electric field is pointing in this direction, di ba? So as you can see that dili kay makita sa drawing, but as you can see that the vector area sa rectangle is in the opposite direction as your, so dili mong vector area sa rectangle is opposite direction as your electric field vector. So what is the angle between them? So that is 180 degrees. So we have here, so we have to multiply 7.80 times 10 to the 4 with the area of the rectangle. So we have 2,340, and cosine of 180 is negative, so that is negative Newton per coulomb times meter squared. So ito yung electric flux mo for a rectangular surface here, ito. How about for the slanted? So the slanted one is, again, we have E dot AS, the slanted of the area, slanted area mo. Okay, so we have here E AS, tapos we have cosine of phi S, so the angle between the slanted surface at saka yung electric field mo. again sa slanted surface mo is yung electric field vector of that slanted surface is again perpendicular. So ito siya with the A ha, ito yung A mo. So the angle between your AS tsaka ni E is again equal to 60 degrees. Same sa akong gihatag nga example ato nga in the slide, di ba? So yung angle mo dito is the same as angle here. Okay? So therefore, we have here E tsaka the area of the slanted tapos cosine of 60 degrees. Okay, so what na type problem question ani? So basta pag rotate niya, ang imuhang AS will the same direction kanang mo sunod siya. So the amount of rotation or the amount of angle nga ni-rotate siya from katungkuan pa siya state is equal to the angle between AS tsaka ni E. Okay, so how about your AS? So AS is equal to again, so suppose ito ay a rectangle, so we can get the rectangle nga area as length times width, di ba? So the length is supposed 30 cm or that is 0.3 meters. How about yung width mo? So ito. So we don't know anything about the width, but we have 10 cm at saka we have 60 degrees. So this will help us to, so since these are right triangles, so we will use the cosine relationship. Okay? So the cosine of 60 degrees is actually equal to adjacent na side, which is 10 cm, divided by the hypotenuse, which is our unknown. So hypotenuse, or which is our width. So we can say here that your width is actually equal to 10 centimeter divided by cosine of 60 degrees, which is equal to 0.1 meter divided by cosine of 60 degrees. So I will just replace the width as 0.1 meter divided by cosine of 60 degrees, and I will put this one here directly. Okay, so we have here the flux through the slanted surface is equal to the electric field magnitude of 7.80 times 10 raised to 4 Newton per coulomb. Multiply this one with the area of the slanted surface, which is equal to 0.3 meters. Tapos meron tayong 0.1 meter divided by cosine of 60 degrees. Then multiply again with cosine of 60 degrees. So cancel this out. So we have the same tayo nang nakuha dito, diba? So we have still equal to 2,340 Newton per coulomb times meter squared, but this time this is positive. Okay, so mag-cancel out man ang cosine of 60. Okay, so let us see the entire surface. Okay, so again, rectangular box, may apat tayo na surface ay 5. So we have the rectangular box, kaning slanted surface, tapos ito kani siya, kaning the other side, kasi closed triangular box siya, napod tayo other right triangle diri, napod tayo rectangle diri sa ubos. Okay, so the flux contributed by this triangle here, so can I get A triangle 1, and dito is si A triangle 2, wala sila contribution kay ngano gani, so walay ni penetrate nga electric field lines in that specific surfaces. Okay, and then also the electric field vector is in 90 degrees with the vector areas of the two right triangle. Okay, how about katong higda nga rectangle diri? Okay, still wala siya contribution sa electric field lines because ang iyang electric field, ang iyang vector area sa nahigda na rectangle, okay, so is in the 90 degrees with the vector E. So wala siyang contribution ng electric flux. So the total electric flux lang is coming from the we just have to add all of them. So we have negative 2340 Newton per coulomb times meter squared plus ito naman 2340 Newton per coulomb times meter squared plus katong other contribution which are all 0, then the total electric flux is actually equal to 0. Okay, kasi mag-cancel out ang 2,340. Okay? So that's it. That's the electric flux. So we are done with electric flux. Now we are going now to Gauss's law. Okay? So alam niyo na ang concept ng electric flux. So Gauss's law is actually using electric flux as the main variable niya. Okay? So again, Gauss's law is used to simplify electric field calculation. So hindi na tayo di na ta sige og integrate sa katong mga kuan kana with a very long derivation of integration kung wala tay table of integrals, di ba? But ang Gauss's law will only be applicable for those charge distribution na naay symmetry properties. So dili siya always true for those charge distribution na walang enough symmetry. So I will tell you more on that later on, okay? So let's just have a conversation with charge and electric flux. So ano pala yung relationship ng charge at saka ni electric flux? Okay? So suppose I have here a box, okay, a closed box with an unknown amount of charge. Hindi natin alam kung ano yung nasa sa sulod, kung naaba siya positive charge, naabay negative charge, naabay positive 1 column, naabay positive 2 columns, negative 3, and so on. So hindi natin alam. So in order to test if naabay charge or wala sa kaninga closed box, what you're going to do is you need a test charge. So the test charge will experience a force, will interact to the box depending on the sign or the amount of charge. So for example, if repel siya sa imong positive test charge is i-repel siya sa box, this means nga naa siya positive charge sa sulod. However, if yung positive test charge mo is kanang gi-attract sa box, this means that ang sulod sa box nimo is a negative charge. Okay? So that's it. That's the relationship between charge and electric flux. And remember, if your box encloses a charge that is positive, iyahang electric field na ipagawas is outward, diba? So you can see here sa inyong electric field lines. So this means na imong electric flux for a positive charge is actually outward. So naatay outward electric flux, meaning sa outward positive. So kung naatay ani negative nga charge sa sulod enclosed by the box, so what will happen is ang electric field nimo diba is iyahang i-drain tanan, diba? So as you can see here, pointing towards the charge. So therefore, ang imong electric flux through that area is an inward electric flux, meaning negative iyahang electric flux. Okay? So yeah, that's it. That's the relationship between charge and electric flux. Now another way to state Gauss's law is, how about if naatay what are the three cases where we have a zero total flux or zero net flux? So net means total. Okay? So first one good that you're going to, the first case where you have a zero net flux is there is no charge inside a box. So for example, ito yung box in question mo, tapos walay sulod nga charge. Therefore, the electric field or the electric flux is zero. Kaya in the first place, wala man siya source of electric field. Kaya wala man kay source charge sa sulod. So therefore, wala siya electric field. and wala siya electric flux dayon. So another case is if we have a zero total charge inside a box. Okay? So for example, na kay dipole sa sulod. Okay? Na ako'y positive Q and negative Q. Now if you will add all of them, so the net charge is actually equal to 0, di ba? So nganong mag-zero man ang net flux diri with zero net charge? Because ang inward flux coming from negative Q is equal to the outward flux. So meaning mag-cancel out lagi hapon ang iyahang contribution, di ba? So kung unsa to ni gawas ng electric field, mao po to ni sulod ng electric field sa negative Q as long as we have a zero net charge. Okay? So mao na siya. So how about the next case is wala tay charge sa sulod sa box pero naa tay charge outside the box. So what will happen is again, so suppose na ako uniformly charged sheet nga naay positive sigma, naay surface charge density nga positive. So what will happen is ang iyahang electric field is pointing away from the sheet, di ba? So we have here musulod sa box ang imuhang mga electric field lines coming from sigma. So what will happen is ang musulod diri nga kuan nga electric field lines is equal to mugawas nga electric field lines, di ba? So therefore mag-cancel out ang gyapon ang contribution sa electric flux. Okay? So take note ha, ito ay zero net flux, meaning that you have to add all of the electric flux on the surface. So kani nga surface, kani and so on. Okay? Pero what if mo na ko naa ba siya flux on this surface? Of course naa siya flux on this surface. Okay, na po siya flux on this surface. Pero iyang net flux, the total flux is 0. Okay, so take note of the flux at saka net flux. Okay, kasi mo Gauss siya sa exam basin. Okay? So kaning pinakalas nga case, so one way to explain this one is kani siya nga example, di ba? As you can see, walay sulod ang imuhang box nga any charge, pero naka-electric field lines nga penetrate without knowing na asa ni siya gikan, di ba? So as you can see, even though naiga penetrate ng electric field lines, the total electric flux is still equal to 0. Same also as this one. So same lang sila ng situation sa case number 3. Okay? So 0 yung net flux niya. So another statement of Gauss's law that we are going to discuss is the relationship between the magnitude of the charge inside the surface at saka the dimension of the surface or the closed surface. Okay? So suppose I have a positive charge here. Okay? So makita na ako nga na ako electric flux diri tanan so on. Now, if we will increase the magnitude of the charge, of course, daghan po yung electric field lines twice as much as this positive Q. So therefore, the electric flux over the surface increases. Okay, kinisaka man ang iyang amount of charge. So therefore, the amount of charge is related to the strength of the electric field, which relate also to the electric flux. So the greater the amount of charge, the higher the electric flux, the larger the net flux. Okay? So how about if we have the same again nga positive Q, okay, sa sulod, pero atong gi times 2 ang iyahang dimension. So doubling the box dimension. So what will happen is it will not change the flux. So the flux here is actually equal to the flux here. Okay, nga naman. So again, please take a look at of this Microsoft here. Akong i-explain. So I have here a box. containing the positive test charge. I mean positive source charge, not test charge. Okay, so electric field lines niya is kani, kana, and so on. Now, how about if na ako'y positive test charge sa sulod, pero na double na iyang dimension. Okay, so I have here kani, ni double na, dako na siya. So what will happen? Is the flux remains the same? Yes, of course. So one thing to explain this one is the definition of electric flux. So suppose, remember that the electric flux is, suppose we have E tapos A, diba? So approximately lang. Okay, so mura siya proportional to E at saka A. Then proportional, yung electric field mo is proportional to 1 over the distance, R squared. Diba? Then yung area A mo is proportional to say the length tapos the width of the surface. So we have here flux is equal to proportional to 1 over R squared coming from the electric field, tsaka yung length mo ay yung area mo is say L width. Okay, so let's look at this one. So if we double the dimension, this means nga ang distance between the positive Q, so again ha, yung positive Q mo is exactly in the middle of the box ha, so mag-double po siya yung distance niya, diba? So approximately magiging ganito siya. So we have 2R squared, tapos yung length mo is mag-double naman yung dimension, so we have 2 times L tapos 2 times width. So this will just cancel out the 1 over 4R squared, tsaka meron kang 4LW. So we have the same electric flux na L over R squared, or that is equal to the flux na original. Okay, so yeah, that is for quantitative. Now how about for atong observeran? Okay, so diba kung magkalayo ang imong electric field, magkadako pod ang spacing sa imong electric field lines. So for example, na ako'y positive Q diri. Okay, kung magkalayo ang imong electric field, magkalayo pod ang iyahang spacing, di ba? So saan niya siya pag, so kung magkalayo iyang spacing, so kung magkalayo siya kay ni double man siya, meaning the same na di ay ang ni penetrate ani nga surface. Okay, so same lang gyapon ani nga electric flux. So the number of lines here is equal to the number of lines nga na-penetrate ani. Kaya ngano gani magkalayo man ang imuhang electric field lines kung kung mo double ang dimensions sa imong box, 'di ba? So therefore, and of course, mana mo nga, okay sir, pero ang electric field man kay mo decreases man as time as kumulayo ka. That's because ang kaning nga pag-decrease niya is actually na compensate or na neutralize sa pag-double sa imuhang dimension. Okay? So that's the essence of this one. So therefore, independent na siya sa surface. So even though imong i-triple, i-quadruple ang dimensions among surface, it will not change the flux as long as they have the same net charge inside the closed surface. So ang imuhang electric flux lang through a surface is dependent on the charge enclosed or the total charge enclosed the surface. Okay? So there are actually 3 qualitative statements because of those na mga situations. Okay? So first one is the net outward or the inward electric flux is based on the sign of the enclosed charge. So the sign of the enclosed net charge. So if ever imong net charge is positive, then naakay outward electric flux, naakay net outward electric flux. But if naakay negative nga enclosed charge or net charge, then naakay inward electric flux. Diba? So mao na siya ang first statement. The second statement is the charges outside the surface do not give a net electric flux through the surface. Take note of the word net. So although maghatag siya electric flux katong mga charges outside, but ihang total contribution sa electric flux will cancel out. So therefore wala siya net electric flux through the surface. Then the third one, the net electric flux is only proportional to the net charge enclosed in the surface and independent sa imuhang closed surface. So the size of the closed surface, kung imo mo siyang i-double yung dimension, imo bang i-triple, it doesn't matter. They have the same electric flux. So imong electric flux lang is directly increases if you increases the net amount of charge enclosed in that surface. Okay? So ang ilamong electric flux lang yun is magdepende over that surface, magdepende na siya sa katong sa enclosed nga charge. Okay, so mo wala. Okay? So, yeah. So, recall that the general expression for electric flux is given by this. So, we have phi is equal to the integral of E n hat dA. So, we have this one. So, ang Gauss's law nimo states that the net electric flux through any closed surface is proportional lang sa amount of charge or the net charge inside the closed surface. Okay? So for example, so how can I get the electric field using the Gauss's law? So I have here a charge, a point charge in space. Tapos ako siyang i-enclose sa ako ang sphere. Okay, so sorry, di siya perfect na sphere, okay, positive. Okay, so therefore ang iyang electric field lines is pointing away from the charge. So we have here ana, di ba? So this is a sphere where your positive charge is exactly in the center of the sphere. Okay, so walang siya na center pero yeah, center na siya. Okay, so the electric field of that point charge is, di ba? Using the electric field magnitude, we have 1 over 4 pi epsilon sub naught q over r squared. So that is r hat, diba? So the magnitude is, of course, we have 1 over 4 pi epsilon sub naught q over r squared. This is actually the magnitude. So suppose lang, so this is actually the electric field due to point charge. Okay, so if that is the electric field due to point charge, so how can we get the electric field using electric flux? Concept of electric flux. Sorry. So remember nga imong E over this surface is uniform. Nga naman kaingon man kog uniform because naa may enough symmetric man imuhang positive test charge to the sphere. So meaning at every point on that sphere, ang makuha nimo nga electric field is still equal to this one. So we have a constant electric field, so I can put it outside the integral. Then your dA for each surface naa siya equal nga 4 pi r squared. Suppose ang imuhang ang radius sa imong sphere is equal to r, small letter r. So each of the surface area is equal to 4 pi r squared, di ba? So therefore naa kay times 4 pi r squared. Okay? So the electric field of that point charge is actually equal to this one. So suppose mo na siya, so we have 1 over 4 pi epsilon sub naught q over r squared multiply with 4 pi r squared, and that cancel this out, cancel r squared, so we have q over epsilon sub naught. So therefore di ang imuhang flux is just equal to q over epsilon sub naught for any surface. Okay, again, hindi siya magdepende sa surface nimo. Sphere ba siya, cube ba siya, or unsa pa na siya nga other surface diha. So the electric flux is still the same nga q over epsilon sub naught. But you can also try to solve the what if ibutang nato si positive test charge in a cube. You can actually solve nga makuha lagi po nimo ang q over epsilon sub naught. Pero that is very taas na siya nga. It needs very long derivation. So mas better if we can use a sphere which is symmetric to the positive test charge. Okay, symmetric meaning that each point on the surface kay naa siya magnitude ng electric field equal to this one. Okay? So therefore the Gauss's law is equal to the integral of E dot dA is equal to the Q over epsilon sub naught, where your Q is actually the enclosed charge. Ako na siyang ibutang enclosed, and this is actually a net total. I mean the total enclosed charge on the surface. Okay? So mo na siya. Yes. So that is the electric flux. Okay? So where your E sub naught is actually the permittivity of free space. So I already discussed about that tong sa pinakauna pa. So we have here, how about sir that you have i-increase na po nato ang dimension. Again, ang imong electric flux, so again mas better nga imong i-let ang imuhang sphere as the Gauss's law as sphere, 'di ba? So makita nato nga kani siya kung imong i-increase ang yang dimension or radius sa 2r, we still get the same electric flux. As you can see here nga same lang gyapon ang yang electric flux kay magkalayo man gihapon ang iyahang electric field lines kung magkalayo ka sa source charge, diba? So you can see, so natay 4dA diri, same gyapon electric flux sa dA. So 4dA mean nga gi-twice na nimo imuhang radius kay mo na kay 4 diha. So diba, so you can see same lang gyapon electric field lines ang intersect sa imuhang 4dA, same sa dA, diba? So naitulo pud sa 4dA. So same lang gihapon. Now how about sir if na ako'y irregular nga surface or dili siya non-spherical surface? So can we still get the same Gauss's law? Yes, of course, we can still get the same Gauss's law. Why? So suppose na ako'y again as a sphere nga gi-enclose ni positive q nga radius r. So na ako'y non-spherical surface, you can see here. So if I get a dA na directly above sa imuhang normal sphere, mo ni ang imuhang non-spherical surface, so what happen is this, dili na siya in the same orientation as your dA, diba? Kani siya kay dA is the same orientation as for dA, diba? Same sila nga gain-an na. So kani siya is naging-ani siya, kani kay gain-an na siya. So meaning what you will get is you have to get the projection of this dA towards the direction of your kaninga dA para you can get the total electric flux. So the projection, remember, is actually equal to cosine of phi, and the integral here is actually equal to E dA cosine of phi. So we still get the same electric flux even though the outside the outside surface is non-spherical. So we have the same same na kanang electric flux. Okay, kasi ED ay cosine phi. So same gyapon ani. So how about ditong perpendicular na to na electric field? This is actually coming from, again, itong pag-project mo ng pag-project mo ng DI cosine phi will actually make the projection pod ni E. Diba? So suppose mao ni siya imong DA. So dito yung electric field kana ay angle nga phi with respect sa perpendicular niya. So it's either you can use E cosine phi para makuha nimo ang electric flux, or you have to project dA cosine phi. It doesn't matter. Kaya ngano gani siya kani siya na integration man good. We have here E dot dA is equal to E dA cosine of phi. So it doesn't matter, that is you get the projection of dA or you get the projection of E, kasi if you get the projection of E, so we have E cosine phi with the same area dA, case that is still correct. But now if we get the projection of your dA in the direction of your E, so that is still correct. So it doesn't matter kung asa i-project nimo. So same lang gyapon sila. So mo nang pasabot aning naay E perpendicular diri. Okay, the outward normal makes an angle of phi with the direction of E. Okay? So the total electric flux is still equal to Q over epsilon sub naught. Okay?